Hi everyone, this week we're going to be working on the lab called the properties of oxygen gas, and there's really two goals in the lab. One is you want to run a reaction to produce oxygen gas, and then the second goal is to then investigate what the different properties of oxygen gas are. So we're going to first talk about how we get the oxygen gas, and then afterwards we'll talk about some of the terms that are related to oxygen gas when it reacts with other things. Okay, so just a quick start here. How are we going to get our oxygen gas? Well, we're going to do it by decomposing hydrogen peroxide. So hydrogen peroxide is a compound that you can get actually from the drugstore, and all you need to do is let it decompose, which means it breaks down to form water and oxygen gas. Now, if you let it go on its own, it will take forever for this to happen. So what you do is you add something called a catalyst, which is a compound that helps to speed up this whole process. So the catalyst that we're going to use in this reaction, there can be many different ones, but the one that we're going to use is yeast. So the organism yeast helps to convert hydrogen peroxide to water and oxygen gas. Let me just talk a little bit about how that's going to be done. So you're actually going to have your hydrogen peroxide in an Erlenmeyer flask, and then afterwards there's a tubing that comes out from here that allows the oxygen gas that's produced to bubble up through water. So this is what we call collection through displacement of water. So the oxygen gas is going to bubble up because it's not as dense as water is going to bubble up to the top. The second reason is because the oxygen gas doesn't dissolve in water. So some gases can dissolve in water pretty well, like ammonia, for example, but oxygen doesn't dissolve much in water. So when it's formed, it's going to separate into a different phase, which is the gas phase, and the water gets pushed down all the way to the bottom. So eventually when this tube or this bottle is completely full of oxygen gas, the whole thing will just look transparent to you because gases are not visible to our eyes. So all the water will get pushed down. So basically you're going to keep collecting this in different bottles until you have enough samples of oxygen gas to do all the other experiments. Now, a couple of things about oxygen gas. The way we call a reaction where oxygen gas is involved is a combustion reaction. So keep that name in mind. Combustion just means burning. So when you burn something, you need oxygen for that process to occur. And what you get are called the products of the combustion, and you usually also get heat as a result of a combustion. So you can combust an element or you can combust a compound. So if you have an element that you're combusting, some of the examples are given here. The typical product is called the oxide of that element. If you have carbon combusting or reacting with oxygen, then you get carbon dioxide plus the heat. That's also the product. If you have mercury being combusted, then you have mercury oxide. And of course, this could be either mercury 1 or mercury 2 oxide. In this case, it happens to form mercury 2 oxide and heat. All right. So once you have the oxygen gas, you're going to be running a few reactions with the oxygen gas. And I'll just say here that the main thing that we're going to want to observe here in this reaction is really what kind of changes you see when you have the compound or the substance being reacted with oxygen. So you're going to combust wood, you're going to combust candle wax, sulfur, iron, hydrogen, and magnesium. And particularly what we're interested in looking at the difference between how the substance, which is the wood, the candle wax, sulfur, etc., behaves when it's being combusted with pure oxygen, which is the oxygen you generate here in these bottles, versus air, which only contains about 20% or 1/5 oxygen gas. The experiment you do is going to show the differences between these two, and that's the observation you're going to make. And that's pretty much it. There's no actual measurement in this particular lab, so it's really just about observing how oxygen gas behaves